So yes, I'm a principal engineer. I'm a software engineer. I've been working around networks my whole career. And it's worth me introducing myself so you understand the perspective I come at SDN, this wonderful disruption from, and what I'm excited about in it, and how that's leading to these 20 slides I'm going to show you. In 1992 or so, I started working on the second release of a large enterprise network fault management system that has a lot in common at its core with very different implementation technology to the OpenDaylight core. And I've been working on the core of a multi-layered modeling engine. It was largely SNMP based. So I've been working around networks that are already configured, trying to provide a NOC with a great fault management and performance management single pane of glass to operate a network on. And yeah, I'm a product delivery guy, so I don't like to talk about things that aren't real. So you're missing Tom Nadeau, who couldn't be here because he's in an airplane. I worked with Tom for a while at this company where this network monitoring tool was, and he brought myself and several of the other core guys in. And so what we're really excited about is network monitoring has been a silo separate from network configuration. There's many traditional silos, and there's so much more that our code could do if you brought those silos together. So we're excited about bringing together end-to-end a view of the network from provisioning all the way to monitoring, as well as enabling all the dynamic capabilities that networks need today in our more SDX world. So this is a great slide because it puts in mind Lego blocks, which is going to be a theme of my slides, a hidden theme. And also it points to the confusion and how, because who really knows where this wonderful disruption will lead and what that real SDN controller needs to be. It needs to be a platform. And we do know we've built a lot of platforms over the decades, and we've learned a lot. And OpenDaylight has leveraged a lot of that knowledge. So I'll just quickly, you guys all track OpenDaylight.
A little bit.
So you've looked at what's coming in Helium. There's an awful lot going on in OpenDaylight. There's 22 separate sub-projects of OpenDaylight. I don't track them all. I'm a core guy. I want to make sure that the core of this thing becomes real, stable, that it's usable, it enables innovation and rapid development of real applications. So here's a few things I thought I'd point out that are coming in Helium that are of interest from my point of view. So we support OpenFlow 1.3 now, and that's now secure, and it's vendor extendable. So as non-standard or non-compliant behavior occurs, a vendor has the freedom to extend the plugin with a vendor modification. So it's matured quite a bit there. If you followed OpenDaylight recently, the community realized that they need to move the technology of the container, the runtime that actually ships this modular system. They've adopted Carafe, which is an Apache project around OSGI. OSGI mean anything to you? OSGI is the container that takes an awful lot of Java code from separate sources and makes it possible to put them all in one process, one big multi-threaded process, and ultimately promises to give you runtime cycling of modules, so you can do upgrades, live upgrades, and
and Carafe is actually an implementation of OSGI, right?
Yeah, it's actually a wrapper around the core OSGI
like OSGI
container.
plus some.
Plus something, yeah. So it gives you features of the real thing it gives you.
Gotcha.
Like there's 270 odd jar files that go into a controller runtime today. That's about 20 different, meaningfully different functional groupings of things. Craft lets you create those 20 groupings. They have names that are meaningful. A support person can say, I need to restart my whatever module. Craft gives us that. It also leverages some powerful ways all around the life cycle of that runtime that needs to be highly resilient, supportable, extendable. The two other big core developments are the northbound API, RESTCONF. So RESTCONF is a draft standard, and my architect mentor always told me, no matter how good or bad your standard is, have a standard. So RESTCONF is a standard, and that is the form that the northbound API is taking on this controller platform. And so any new model you introduce to OpenDaylight will appear through this standard API. And if you want a single pane of glass, you want to plug an analytics brain into something, you need a common API.
What is in your opinion, what's the general confidence level of projects across the board? Because they start in ADSAL and they migrate into MDSAL, right? In general, the confidence of doing that action, of putting them in that model-driven SAL. What's your take on that?
You can go today and look at the state of the Helium release, and there's a nice matrix that shows color-coded green, yellow, red.
Do you think most of the projects are looking to do that, or maybe they're holding off?
The core projects, all the core projects, and slides forward will mention the ones that we're watching, are all heading to MDSAL, model-driven, Yang-based, RESTCONF, northbound.
Yeah.
The OpenFlow plugin, MDSAL. So.
Yeah, there's a lot more work involved with doing that, so I didn't know if a lot of projects were looking to do that in the Lithium time frame or something like that.
Yeah, all the ones that we've been focused on, whether reluctant or not, they've all committed to going to MDSAL.
Rock on.
Everyone sees that it costs to build a platform. You've got to pay up front for unrealized capability. But if we want this to survive the evolution of the disruptive confusion and
Sure.
Be a place to plug in Dave's self-learning brain, you need to commit to a standard model, really.
Yeah.
Is MDSAL beginning to kind of stabilise off? I mean, myself and Matt chatted about this, but there's more work involved, isn't there, in doing something with MDSAL than just kind of tapping the southbound libraries directly? Yeah,
and if you want to do a prototype SDN application that does one simple thing, MDSAL is a long path.
Yeah.
If you want to build a real system that you can extend quickly, that takes advantage of other Lego blocks, you need more than an ADSAL, because a controller is not an iPhone that you throw 25 separate apps in. It's a layer of applications.
Yep.
So you need MDSAL to plumb those 20 applications together.
Yeah. Otherwise, it's a collection of APIs.
Right.
You mature that northbound API by forcing everything through the same generic model, and you mature that model as a result because you get more use cases underneath.
Right.
Stabilisation is key, isn't it? To try and use that, the things have got to be stable enough to put those things on. Else, if things keep changing, then...
We at Brocade are committed to that stability, and very quickly, we have 2 committers on the core controller, MDSAL. In fact, if you go to a MDSAL hackers meeting, it's a Brocade employee that runs that meeting today.
Sweet.
So, and we bring with us Java, OSGI, Carafe, model-driven network monitoring background. So we have some experience that we think is going to help stabilize that. And
so I think this is important to touch upon. Back at the OpenDaylight Summit back in February, people were asking in the general session at the end, well, so things like reliability and scalability and HA, those aren't sexy things. So who's going to, if the governance model is let people do whatever they want, how do we know that those things are going to get taken care of? And so we looked at that and said, that's where we can really invest our expertise, because we have a very strong interest in making sure that OpenDaylight is actually a viable platform for people to use. So that's why we've invested where we have.
Cool.
And the last big thing at the core that you'll see introduced with Helium is there's a first step towards a more ultimate clustering capability that we'll need for this platform. HA is being realized with MD-Cell-based applications. And if you go down in the weeds, it leverages akka, which is a really exciting event-driven library that runs in the JVM, and it takes advantage of very high concurrency capabilities that advanced Java has yielded. So we've already been making the point that Brocade's controller is an OpenDaylight controller. That is our platform. Our customers want it to be an open platform. They don't want to be locked into us. There's a big investment in this as a software engineer, being involved in ODL. The quality of the engineers working on ODL is very high. I've worked on lots of closed projects over the years, and I'm impressed with the quality. So certainly a lot of challenges in working together in open source that we're learning. So you guys know what OpenDaylight's about, and what makes us different from the rest of the OpenFlow-centric controllers is we are a heterogeneous controller. We're better prepared for this disruptive confusion. It's more than an OpenFlow controller. SNMP is part of our legacy network, and how are we going to have a real controller that doesn't get information from the legacy? NetConf, OpenFlow implies, relatively dumb commodity data forwarding devices. There'll be a lot of smart devices out there. Right now, NetConf is the best standard we have for including those devices in a heterogeneous controlled network. And you'll see Brocade committed to both of those. And as well, there's been a lot of activity around OBSDB and BGP LS, which are also OpenDaylight projects, since we're using that platform, even if we're not delivering them directly immediately. When we have customers that have a priority there, we're using the same platform. So we're going to be releasing our Brocade Vyatta controller, which is this core OpenDaylight platform, packaged and distributed with our testing. So we have a big test team growing, and we'll be packaging it from a service assurance angle, so that when you deploy a Brocade Vyatta controller, you have a way to manage it in your enterprise as a critical element.
By the way, while we're on this slide, I want to introduce Kevin Woods. He's the product manager for our controller, our distribution of OpenDaylight.
Hi.
Hey, Kevin.
Good to meet you.
And with all the backing of a 7x24 support organization for those customers who can't directly get involved with OpenDaylight, and they're going to leverage our packaging, and we're going to deliver both support for our own virtual and real devices and third-party devices, which support the standard protocols that these southbound plugins.
How far are you going to go with that support for third-party stuff? Because there's different levels of support, and it's not easy when it's someone else's code or whatever underneath it. It's sometimes people give you fantastic support. They'll even go back around to that vendor if that's what they need to do. Other times it's more like, well, look, we're talking a standard thing to them. If they're not doing it properly well, you should have brought Brocade.
Yeah, reminds me of SNMP in our network monitoring system. We have options. This platform supports someone, could be us, could be third party, could be an integrator, building a translator that plugs in and translates a vendor's view of the standard to the OpenDaylight Brocade view of the standard.
So you guys aren't seeding your own southbound plugin, is what I'm hearing. You're not developing a new configuration protocol. You're choosing to leverage existing configuration protocols.
So I think
We're
that's-
encouraging those standards to become real and participated in.
Yeah, I think it's important to kind of go back up to that first bullet there. The core controller itself is continuously built from the OpenDaylight code. So we're not building extensions directly onto the controller itself. So it's always going to be aligned with the core project.
Well, I mean, for an example, right, like OVS uses OVSDB, obviously,
Yep.
as do some other platforms now.
Yep.
So, that was the reason that project was seeded, is because that was the programmability option of choice. And most vendors are kind of doing that, where they're like, okay, well, we had this API for some time. Now we need to create the southbound plugin in a very open way. I mean, it's not like you're promoting your own proprietary stuff, but it sounds like what you guys are doing is saying, well, we've got enough programmability options out there. Let's not make the water muddy. Let's, for instance, implement OVSDB and use the Brocade schema of OVSDB.
Yeah,
I don't know if that's what you're doing, but
so we've got another diagram later on that will kind of show this to you in a little bit more detail. But we've made pretty extensive investments in OpenFlow, for example, and the core controller can leverage OpenFlow with we're 1.3 compliant. The controller can use the 1.3 interface and so on. So if people have built their own APIs to OpenDaylight, this can consume them, and that's sort of the other important thing here is it's not just for Brocade gear, right? Anybody who has a NetConf interface, anybody who has an OpenFlow interface, anybody who has their own APIs that they've built to OpenDaylight can be running under this controller.
your value is that you've said, here's this platform that's already been built. These protocols are good enough. Let's package it and make it, QA it and all that stuff and put it in a validated design.
Exactly.
Yeah.
But what about for Brocade hardware and the vRouter? What protocols are used for those devices?
We've committed to OpenFlow and NetConf.
So configuration protocol will be NetConf across the board, and OpenFlow for flow instantiation. Okay.
And we even have opportunities to use one-offs, but we've purposely said, no, we don't want to.
No, that's fine.
Yeah.
You need one of both, and I was just curious exactly what those would be.
And let's say the vRouter, for example, like that specifically, will that be both or just NetConf?
Just NetConf with current
good
current requirements.
Interesting.
Should out of this disruptive confusion another standard emerge, we have a great architecture to plug another southbound plugin and map that to higher level abstraction models that real applications are built off of. All right, so we've been demonstrating our integration with OpenStack as well, with the Neutron plugin, and we're doing what we can to make Yang a modeling standard reality, encourage best practice, and get engagement from all the stakeholders, which isn't just the vendors, it's the end users as well. All right. So if we can go down a level, I'm guessing you might be interested to take the hood off and see what goes on inside of this new evolved Helium SAL, this service abstraction layer, and how Yang files turn into something useful, what's auto-generated, and what you need a developer for. So as I was just saying, the platform allows for innovations or Yang models to be defined from the top down, if you will, from applications and users who want a model that defines something useful at their level. And it enables the lower level network supplier to provide a model of the data that's available from that device, as well as the configuration that's available on it. So the Yang tools, which it was in Hydrogen, it's evolved and matured since. From Yang tools, you generate an awful lot of Java code that runs inside the controller and does a lot of the boilerplate to represent that model. In fact, if you simply define a Yang model, which SNMP MIBs. A Yang file is an evolution of defining a MIB, has more modeling capabilities. If you define that model, run it through Yang tools, you immediately, through that standardized RESTCONF API, can do CRUD, create, read, update, delete operations on the objects that Yang model represents. The notifications and the RPCs are stubbed out. You can't connect that model directly to any other model to do anything useful yet, but the system has auto-generated for you much of the boilerplate. You don't need to do anything to see it through the northbound API. That's a big advantage of the system. You do need a developer to implement the model's behavior and to interface with other models, especially your southbound plugins, which are also models in this model-driven SAL. In fact, if you were a developer building this, you wouldn't think of north and south here. Everything's built around this core. Everything's a plugin. Everything works off of the modeling API. The southbound plugins are plugins just like RESTCONF is a plugin to the MD SAL. So that, like Dave was up here saying, that learning is simple. Here's your little diagram. The system is actually simple inside because everything is using that common model-driven API. And as I mentioned before, we're using this ACA distributed processing library to cluster multiple instances of this together. Initially, you'll see it provide HA, and then later you'll actually see it shard and scale across multiple nodes. So if you look at a Yang file, it's got a lot of obscure syntax, just like an SNMP MIB does. It's good to stand back and say, what are you defining in a Yang file? You're defining items that have attributes, relationships between items that are meaningful, notifications you can get in the context of those items, and actions you can perform on that item. So enter our Lego block. So you put the auto-generated Yang tools code that represents those items, attributes, relationships, notifications, and actions, RPCs, together with your developer code, and now you've got this building block that from the north you can do CRUD operations, get notifications, and fire actions, and you can do that both from within the controller, from other Lego blocks, or through the northbound API. So when you define a model, you don't know whether it'll be used internally, externally, or both. So you're really building a building block here, and you don't exactly know who's going to leverage that at higher layers in the future. And the other key thing is that it talks southbound to other Lego blocks, which could be a southbound plugin or could just be a lower level building block in a multi-layered model. All that's running inside this controller. And what you tend, when you really start doing this for real, you're going to end up with useful model fragments. So if we stand back a bit and go through a use case that helps justify all this model-driven infrastructure, let's look at a use case. So a customer has initially some Brocade devices. They got a lot of heterogeneous network of Brocade devices, and they all support OpenFlow, and they can provision device by device flows that yield paths across that network, but they have to understand OpenFlow to do that. and they've got a lot of operators. They just want to connect IP address A to IP address B. Why can't we give them a model at their level? So enter our model-driven controller, and what we've designed is this path model. It's a unidirectional path from A to B, and we'll use a extra shortest path algorithm to calculate through the physical topology a shortest path, and give them the option to drag and drop waypoints in that path, and then we'll, at the lower layers, reprogram OpenFlow for them. Now you've got a network engineer thinking about network services, not about low-level protocol manipulation. So hopefully we've taken the technician up to the engineering level here.
Nor necessarily programming, it might be noted.
Yeah, with the northbound API, you've got options for fairly simple scripting, or if you're trying to make the controller smarter, you could write Java code that manipulates that path model.
Now, this drag and drop flow modification behavior you're describing, would you do something like that for service chaining, or is that a separate application?
Yeah, this will stimulate a lot of service chaining thoughts. I don't clearly understand what service chaining is in your minds. If it's the
I call it poor man's service chaining.
okay. What I'll show you is implemented is a way to program flows in a path. Hopefully, it will stimulate lots of other things you could do with this if you enhance the path model to be a chain of services or.
So really, this is primarily a GUI function or a GUI application, right? But it's something that allows you to visualize how you might do service chaining using other techniques.
Mm-hmm. Well, remember last field day we did the whole when KLF was explaining the Yang stuff, right? And their specific use case was normalizing configuration syntax. Like when I create a VLAN, I know that ID is a kind of a universal constant, but the syntax with which I program that into a switch changes from vendor to vendor. And this is kind of the same way. Like I know what a path is generically, like I know how to describe that, but changing that path on switch to switch is a little different. And so this essentially normalizes that for us.
Right, and in fact, if that path talked to a netconf lower layer, you could have a heterogeneous and non-OpenFlow portion of a path program.
And your experience with changing that path would not change as a result.
Right, and the application you build on top of the path model works.
Yep.
Sweet. All right. So to visualize this, you've got a heterogeneous network. In this case, they're all OpenFlow, but you can visualize that topology. What you're looking at here is actually an early deluxe-based view of a Brocade UI that uses the RESTCONF API to get the topology information, to plot the icons, the links, showing the physical topology, which was LDP discovered. And then the red arrows are showing you the current flow implemented path from A to B. And with the UI, you could drag one of the waypoints over to the other side here, and that would cause the path intelligence to reprogram the flows to take another route.
Is there any way to put any kind of where you wouldn't mess things up, so to speak? Like if you're breaking some sort of rule by dragging and dropping it over there, that could say, no, you're not allowed to do this, or some sort of level of...
Like a validation or something?
Yeah,
that this is a legitimate thing to do, or you...
Like this is a PCI compliant, you can't drag the flow over there, something like
Sure.
that.
Yeah, this simple model doesn't include that, but sure, when you made this real, you could intercept the drag and drop RPC and run it through a validation and reject it. So sure, you can make your model behavior more and more complete.
I guess it's just a case of adding some like metadata or something to various paths, and then just kind of
Yeah, you probably have to enrich your Yang model with the validation semantics.
Where do you see that being used most, I suppose, in terms of, let devices, do what they do best in terms of L2, L3 and use this as an overlay on top of that for specific flows? Or is it, ground up native OpenFlow on every device in that path and only OpenFlow?
I wish we had time to show you a netconf and OpenFlow heterogeneous implementation. The architecture entirely supports it. Just a matter of time before we show you that. I want to show you a heterogeneous network and a controller that handles both through an abstracted common model. That does that, I don't know if that answers your question, but.
Sort of. Well, again, even without seeing it, what's the expectation for adoption in terms of deployment environments? Like what do those environments look like in your minds to where this controller will be used with Brocade equipment?
Kevin, I don't know if you could.
I think, are you asking what the use cases would be?
Yeah.
So, any sort of traffic optimization, path manipulation, overlay topology manipulation.
So is it
service configuration, service sequencing, service stitching, if you'd like. I call it poor man's service stitching, but this is we're showing you a very low level primitive, a very low level function that could be used by higher level applications or policy applications for almost any network configuration use case.
So is it, again, going back to like an 80-20 rule, is it 20% of the traffic you might want to manipulate, the other 80% can just do traditional, again, L2, L3 protocols?
Yeah, and it doesn't have to be somebody sitting at a screen doing this. We put a GUI on this to show you, sort of create a demo of the power of the controller, but that you can manipulate paths in such an easy fashion across any vendor's equipment. We're trying to showcase the power of OpenDaylight and the architecture.
Sure.
So a quick little excerpt of the Yang model that defines this path. It defines a module, the namespace, and it imports other Yang files. So you're always, like with a MIB, you're always building on other building blocks. And then to pull out the core, there's quite a bit of syntax I've excluded here. But there's really three key attributes on this model. There's no RPCs, and so there's an implicit action here. When you create this model, it's going to go build the path. Probably not the best production model. You could enhance it and provide RPCs to make it real, provide a validation RPC, to answer the earlier question. But the core concept here is you've got a source address, a destination address, and an optional list of waypoints. If they're not specified, it's going to use a Dijkstra algorithm. And there's also a couple other attributes I haven't shown. We don't hide anything in the Yang model. So through RESTCONF, you can see really internal private attributes and public attributes. We'll see if that evolves in the future. But once the path is calculated, there's a hops attribute, which is really the relationship. It has pointers to all the objects in the cell which represent the path. So how would this look without a UI if you just brought up a REST client in your browser, pointed it at the URL to this path model, which is your controller's IP, this RESTCONF config URL, and then the identifying attributes, source and destination IP address on the path model. And we're going to do a HTTP put on that URI with this payload, which is this is a JSON format of the Yang defined payload. So we'll do that put, and we're not going to get anything back. We're going to get a HTTP 200, all was well. So, and this is what that UI is going to do under the hood. or any Python script you write that interfaces with this. So let's go back and see what it did. We're going to go to the same URI, do a get, and we're going to get back. You can get XML. I formatted it for JSON. It's your choice on the header. Here's that hops attribute that's been populated using the Dijkstra shortest path algorithm because I didn't specify any waypoints. And it's actually showing you port by port the hops, so you see ingress egress through a switch. The one OpenFlow 1 being a switch's ID, :1 being a port on that switch. So if you then did another HTTP put with a waypoint specified, it would recalculate the path, reprogram the flows, produce a modified set of hops, which would be visualized in our UI as a separate red path. Or if you're integrating this to some higher level application, they would just see a different hop list. So we have already gone and developed some command line utilities that use this path model. I wrote them in Python pretty quickly. It uses this paths module, which I think we'll see an evolution where Yang tools will be auto-generating Python modules that do all the basic boilerplate JSON interaction with the URLs. So programmers at the Python level up above the controller can simply interact with these clear Yang-defined models like a path and do HTTP puts, gets, deletes on them. And so here's the core of a simple command line UI that would update a path. So why are we building this this MDSAL? You know, this is a lot of mundane work that has to be done. Why are we doing it? Because we want to do things like the path, but we want to do much more than the path. We want to build a much more robust path. We want to build things above the path. We want a policy model that programs your paths. And because I'm in love with model-driven controllers, I want as much of that service intelligence running in that controller that we cluster and scale out. So this is actually quite a few layers that we built on. We started with these Lego blocks already existing in the Helium code base. There was a physical topology, which is LLDP discovered. There's a basic inventory of devices and ports. There's the flow model, which already was introduced through the hydrogen release and the evolution of the OpenFlow plugin. And then that was augmented with flow statistics, a flow statistic model that just layers on top of the flow model. So I didn't show you this, but after you define a path, it might be interesting to go run a report on flow statistics on all those hops. And you can do that very easily because this is a layered model and you have your RESTCONF common pane of glass API. So we plugged the path building block into those OpenFlow and LLDP-based physical topology models. And we did this very quickly. We were pretty excited about it. Hopefully that justifies this model-driven infrastructure that has taken quite a bit of ODL's effort and justifies why Brocade is behind this evolution of the SAL in OpenDaylight. So I think I've already talked through this this layered interaction. So important to realize that those building blocks are assembled and they're running inside of this controller instance. And in the future, you could imagine, and we're not sure when and where this would be needed, but you could layer the controllers. So layers of this model could be talking to a controller below that has lower level models, and through a RESTCONF southbound, a REST southbound. So there's a lot of potential for this architecture realizing an arbitrarily complex layering of low to high level network implementation and services. So
Yeah, I sort of didn't pick up on that earlier, but yeah, once you start saying, well, I can plug in whatever southbound interface I want, and yeah, it doesn't need to be a device at that level. It could be
Right.
something.
Yeah.
yeah, a controller could be seen as just another device in the network from a higher level.
Like that part of your network's controlled by that bit of it, and yeah.
Right.
That's what's most
Exactly.
difficult about those southbound plugins getting moved into the MDSAL, right? Because they have to define not only the API interface to interact with that portion of the that plugin, but they also have to define all of the Yang models that define those interactions and normalize data in that way. And that's why everybody basically does ADSAL first.
Yeah, we think we've made some good progress in breaking down some of the barrier to understanding how do you use Yang tools and build a application. We have had a measurable impact on cutting down the number of Java interfaces that you need to use to implement the behavior once you've imported a Yang file. And I've got a slide that shows as well that we do need to mature the best practices around Yang because there's a lot of stakeholders involved, and we've learned a lot from SNMP. Here we're on that slide now. So Tom Nadeau has introduced a GitHub that says, here, bring your Yang files. Let's start in an open source way, developing new, eventually standard models, or perhaps intentionally one-off models. That was one of the powers of SNMP is you could opt in to the standard MIBs, or you could quickly introduce your own MIB and get to market quickly, or if it was an obscure application, maybe there was never a need to standardize it. We're trying to encourage the application developers, the people who are building for the operator, that high-level view of the network services, and the network vendors who are going to have the more low-level NetConf, OpenFlow type models, to get them to come together and provide these standard and non-standard models in a open source centralized way.
Even with the problem with SNMP, as someone who's had my fair share of pain dealing with it over the years, it's really cool that it could be quickly extended by other vendors, and that made it useful. But everyone had their own way of doing really similar things, and some people made some really stupid decisions.
Yeah,
I don't want to name names, but it's not you. But
and that's why
I hope that we don't.
That's why
we have the flexibility, but we don't go too flexible, if you know what I mean.
Yeah, to come up with that MIB2, that core standard model that you could justifiably whip a vendor for not meeting. We're hoping that the stakeholders will come together, and Yang is pretty close to code. In fact, since you can auto-generate code from it, you could imagine us auto-generating a simulator for it. It could be, we might get the acceleration of it being seen as open source code, not standard body, vendor-dominated, slow standard development. But when we get the right mix of stakeholders interested in adding a BGP standard model, maybe we could very quickly arrive at a very useful, minimalist, what was the terminology, narrow waist standard that doesn't try to be too complete, but creates that common model that all vendors should support and would be driven to by their buyers.
How do you see like a traditional network operator contributing to this in any way?
Well, because we're no longer just talking about low-level protocols that they don't understand, we're talking about paths or policies, or you can imagine them actually, maybe not in the obscurity of the Yang syntax, say this is, I've got a use case, and I can define them in terms of items, attributes.
Because there's a lot of operational implications here, and I think a lot of folks are looking at this space and saying, I want to get involved. This is all very interesting work. It seems pretty relevant to me, but I'm not a programmer. So how do I, how can I leverage my experience operationally in that realm without, having to go through a computer science course over the course of 4 years? Like, how do you think they can make that jump in an iterative way? Like, what's the first thing these guys can do?
Well, hopefully the path example shows them how simple a model you can define and do powerful things. So, and we were just yesterday talking to a large enterprise that wants to define a model but doesn't want to go to the IETF. In fact, they're pulling their operators in to define the model. So I think we're going to need our customers to bring those operators into this,
just to sit in
as a stakeholder.
I want to make it clear, we do expect operators to create models with our help.
Cool.
And actually to mandate the use of certain models in their services. We expect that will occur over time. Mm-hmm. So this is you might look at this and wonder and say, well, could a vendor create a silo in here, right, and lock people in? I suppose, but there's going to be a lot of force and gravity from the community here that we think is going to prevent that, and some of it's going to come from the operators.
Cool.
Maybe a lot of it.
Yeah, I mean, I think that's one of the interesting things about OpenDaylight as compared to some of the other controllers in the market, is because it's not primarily focused on the service providers, or it's not primarily focused on the enterprise, right? We've got people from sort of all areas of the industry who are contributing, who have their own interests and are driving their own interests within that community. And because this is not going to wind up forked off and siloed from the core code, we can make sure that those interests are incorporated into everything that we do and that we bring to the market as well.
Yeah, very cool.
Yeah, so I think there's a lot more we could add here. I could imagine a Yang generator that makes this easier for anyone who can think of a model to produce a Yang file, at least to get started. All right, so with Helium, you're going to see the first step towards a longer-term realization of a full clustered controller. And I think I've already spoken to a lot of this. We've the whole ODL community together arrived at ACA as the foundation for that implementation, and it's right. It's coming at the end game of Helium. I haven't had my hands on it yet, but we're looking to realize that three controllers as a cluster will provide HA. So the data is replicated across the three. You could lose any one node and switch over to the other two and get the same functionality.
In that case, if you had the hierarchical control of the controllers, right, would you actually cluster at two different levels, or have a master that says, hey, this level's really in charge and these guys are sort of sub-controllers?
Yeah, it's hard to imagine a use case where the controller isn't mission critical and that you wouldn't have a 3-node cluster realizing one logical control point.
Right.
So if there were a hierarchy, you would be seeing at least a 3-node cluster implementing a single logical cluster at each level.
But you'd interact with each of those as a unit, as it were.
Right, and here you're going to see we're suggesting you could buy a Brocade load balancer to provide that logical single IP from below. Certainly an option. It now becomes the typical load balancing challenge from the outside.
Use the load balancer between the controllers and the controlled devices.
Right, to provide the single logical controller IP to.
But who controls the load balancers?
Right.
You need more controllers. Buy more controllers.
Controllers.
Recursive.
It's like
Right, so
accidentally shut down your out-of-band management interface.
Right.
So we're delivering really 5 different meaningful things as a Brocade Vyatta controller, and the first thing we've done is join OpenDaylight. We've got committers in the core projects. We're making sure that that's going to be stable, that it's going to be the platform we need. We're going to be building our closed source, or possibly opened up, but applications that run in that platform. Things that are being considered are security, analytics, the traffic engineering, policy, then third-party application support. Because we're selling this commercialized version of this platform, we're going to support our customers as partners in enabling their development of applications on the platform.
So I want to pause a little bit on that because there's kind of a little interesting tidbit that is not well known. Not all platforms allow you to have complete application portability. Sometimes buried deep in the EULA, there is something that says it is our platform, it is our IP, and because you're using it, you do not own it. So that's something to look for. Because this is entirely open source, everything that you build on it is yours. And if you want to keep it entirely to yourself and you never share it with anybody else, because, for example, you're building something that's, something that you're hoping to use for competitive advantage in some way, or that's, something, deep, dark secret about your network, we don't have to be involved at all. If you want our help to build something, we can work on that. If a third-party developer is looking to build something for money and they want to be able to, one of the reasons that an application ecosystem evolves is because there's a standardized platform that is used by a really wide number of people, and that's one of the reasons that we gravitated to OpenDaylight is because we see that platform as being the one that's sort of going to have the broadest industry adoption. And so being able to make sure that any third parties who are looking to monetize their applications have something that can run on this as well as any other OpenDaylight based controller is something that was really key to this design. So everything that is within the controller itself is, as again, continuously built from the core code. Anything that would be sort of value add, Brocade, proprietary or whatever, is licensed separately, so it stays outside that controller.
And then we may be delivering new plugins to OpenDaylight, and make sure that, of course, going to be making sure that our devices, physical and virtual, work with the southbound plugins. And then finally, we already said the commercial platform packaging that we call the Brocade Vyatta controller, that, as has been said, is built from the recent code stream in ODL. We have a minor delay to allow us to validate, verify, and brand and package that current state. Our plan is not to branch off from ODL for the foreseeable future. We'll track with the coming releases and be a adopter of the upstream capability. When we enhance the core platform, we'll be doing it upstream. So we're not going to unless someone holds a gun to our head and says fix this bug and bring it to us tomorrow, we'll be upstreaming all of our bug fixes. And because we have committers on the projects, the turnaround on that is pretty quick.
So what about customer education? So for the commercial offerings, a lot of the partners won't have a clue how to go about installing it, running it, explaining it to customers. So is there going to be a set of kind of courses that you guys are going to put together, or is that going to be dealt with by the wider project?
Yeah, we're investing quite a bit in training, and that is one aspect of the commercial packaging, is that it comes along with documentation and training in addition to the testing and support.
I think many of you are familiar with the state of documentation for the core project. That's actually one of our value adds is
it's one of the red lines
improving
in that state of.
To hear that.
You
the
mean
state of
value-
the state of documentation.
Like value create? I exaggerate, of course.
In terms of sort of the licensing and delivery of it, it is a piece of software that you run in a VM of your choice. We are hypervisor agnostic. We don't care what kind of sheet metal you run it on. That's entirely up to you. That's, in fact, sort of the purpose of software-defined networking, we think.
What about vRouter integration? I was expecting to see just lifecycle management of vRouters. If you want to deploy 10 of them in your environment, multi-tenancy and things like that. Like, is there native? Again, so if it's a Brocade environment, just like that value add of, Brocade and OpenDaylight. A lot of this was good in terms of like the platform, what it can do, and, the abstraction layers and whatnot. But just in terms of just like use cases, in terms of again, this in particular is more just vRouter deployments. Like, is that sort of should we expect to see that within within OpenDaylight?
So are you saying can the controller be used to deploy vRouters or?
Right. And I guess
Okay.
the best comparison, to another vendor would be like an Embrain platform, which manages the life cycle of third-party NFV appliances.
Mm-hmm.
So it's basically along those lines for Brocade vRouters.
Yeah. So we'll use the controller to deploy our vRouter, our Vyatta vRouter, and virtual ADX, as well as all of our physical platforms, and
anybody else's, for that matter.
and anybody else's. So using standard
Out of the
control
box,
interfaces.
sort of with OpenDaylight with this distribution, or is that still?
Yes.
You have to hack away on code to get that working.
No, that'll be out of the box on day one. Yeah, so we'll be making this product generally available in November, and the very first use cases will be running for our own routers and switches, and a short list of third-party popular routers and switches, and we'll be growing that list over time.
Yeah, it's a matter of testing as opposed to actually having to do the code. But so we have some customers that we're doing proof of concept with right now, who have mandated that we have to be able to support anything that's within the controller domain, regardless of where it comes from. And we've said as long as it interoperates with OpenDaylight, we will support that domain.
On the vRouter specifically, the body of work that we had to do was a lot of Yang modeling, but that work is pretty much done. So that'll be out in November as well.
So for that model, like, do you view it as a configuration manager for that example, vRouters?
Yes, exactly. And so we'll be contributing that to the community as a community model, and it'll get hacked, and we'll follow that. So
as one more example in that model, do you envision vRouters deployed, right-click, clone, redeploy different IP, template it, and maybe for another tenant within an environment?
absolutely, you could do that easily with OpenStack, for example, and we demonstrate some of this today with the vRouter.
So I guess, is OpenStack required to do that, or can you do that natively within OpenDaylight and vRouters?
They're complementary to each other, OpenDaylight and OpenStack. A lot of the things in terms of deployment, turning things on, doing very basic configuration or very basic connectivity, heat maps and things from OpenStack are really good for that. OpenDaylight is sort of focused on controlling network elements in use. So traffic management, traffic engineering, path manipulation, QoS stuff, things like that. OpenDaylight's going to be really good at that. OpenStack may or may not go there.
Well, to your point, I think you're focusing on the missing piece regarding compute, right? Because at some point you have to provision those virtual machines that run Vyatta, right? OpenDaylight can't do that. So you need some sort of a workflow engine in the background that calls OpenDaylight once those nodes have been spun up and configures it. But that may or may not be OpenStack. Could be CloudStack. It could be VCAC. It could be something else.
Do you want to go back to the slide that has the Vyatta? I mean the controller. I think it's down there. 22 more down. Two more down. There you go. Yeah. So actually, this is the simpler diagram than the other one we have. But I think this gives a reasonably good view on what we were talking about earlier. So we've made all these contributions to the core platform, as Greg was discussing here. All of these southbound interfaces, these are things that we've contributed for our platforms. Other people have contributed things for their platforms. We can consume those as well. And then, the netconf yang OpenFlow models as well. So in terms of how we license all of this, there's one license for the core controller. Again, anything that is outside of that would not be pure OpenDaylight is licensed separately, so we can keep the core controller pure. And then there's nothing special about the interfaces between our, this and our platforms. They're standard interfaces. So you can use, any existing gear you have. You can use Brocade gear. We're more than happy to make it financially interesting for you to package this together with Brocade platforms, but it's not a requirement. Better be clear on that. Okay. Any other questions before we close things out? I know we've got about 5 more minutes.
Can you discuss some more of the current betas and POCs going on and what's driving, I guess, the methodology behind your contributions?
Do you want to talk to that?
Question was
Just examples of POCs and betas going on.
yeah. Well, we have some POCs. We have some POCs that we're doing right now. I probably don't want to say who they are, who they're with yet. We hope to announce some of that in the future, but I think they wish to remain confidential.
It's more about like the type of business or whatever it is. That's the thing.
Use cases.
Yeah.
Oh, use cases. Sure. Service provider market, carrier edge use cases, both on the PE and CE side. Simple OpenFlow stuff, path manipulation, things like that. Research areas, universities, those sorts of things. We'll get take early in the service provider market for.
One of the things that's interesting about one of the larger POCs we're doing is actually they have some, shall we say, in-house controllers already in place that they've deployed for specific workloads. They sort of got to the point that they realized, we're going to have to make them all talk to each other at some point. And so, what they came to was, this is the common interconnect for everybody. This is how we put them all together, and this is how we make them all talk to each other. And so this is actually, sort of the controller of controllers that will command everything in that particular architecture.